All right, so let's talk about the stability of things that float. So as I indicated in the previous video, stability of structures has to do with the relationship between essentially the center of gravity and the center of buoyancy when you slightly tilt an object. So the structure I have shown here to the left-hand side is an unstable structure. So if I take this long rectangle and I tilt it slightly to the side, what you'll see is that, basically because the center of gravity, basically remains at the same point in a body, but the center of buoyancy doesn't when I rotate the body, you can end up in a situation where the center of buoyancy and the center of gravity for the object actually create an extra torque that actually makes it want to tilt even more. So that's basically what causes instability in floating bodies. And it's usually the result of having a center of buoyancy that's really far beneath the center of gravity in a structure. And so it's actually a little bit more complicated than that. That's not the only criteria. But basically the thing that causes instability is if the center of buoyancy moves in such a way when you tilt the body that it actually creates a torque on the object that further destabilizes the object. That's what causes instability, and it causes things to tip over. So how do we stabilize floating structures? Right. Well, so a couple of things. One, we can try and move the center of mass downward so that the center of mass is below the center of buoyancy. So one way to do that is to concentrate weight towards the bottom of the structure. So, if the density of your structure is not uniform and it's really concentrated towards, let's say, the bottom, then you can move the center of mass below the center of buoyancy such that when you tilt the structure, the center of mass actually moves outward further than the center of buoyancy and counteracts any tilting and causes a torque that actually restabilizes the structure. So this sounds good in principle, but it's actually hard to do in practice. So this is not usually the way you would like to have things. You would generally like to have, use less material and have lighter structures. And you can't always control the weight distribution of, a boat that well, looking at you tankers. There are other ways to deal with that situation. So I think the most common way to deal with that situation is to actually utilize the fact that when you tilt a structure, the center of buoyancy shifts. So basically, here's an example of a structure that is more flattened. So notice that the key thing is that it's more flattened with respect to the initial waterline. And so when you tilt it, actually more of the center of buoyancy changes and more of the structure is submerged, let's say, to the left side of this structure, and portions of the structure are actually removed on the right-hand side, which sort of shifts the center of buoyancy very, very much leftward. And it creates a large buoyant force focused on the left side, when I tilted it to the left. And so that has the effect of restabilizing the structure. So I drew it as a rectangle, but you can imagine that this also works for ships. So if you have a flattened ship and I tilt it to one side, more of the ship will go into the water on one side and some will come out on the other side. And basically, as long as enough of it comes out to counterbalance any sort of shift, then you can you can stabilize the structure in that way. So that actually allows you to build much taller structures. So if you're thinking about building a cruise ship where everybody wants to hang out on the 10th story of the ship, you need to think about these sort of things and make actually wider ships, shallower things that are a little bit shallower. And try and shift the center of buoyancy to a restoring side of the ship as it goes. Yeah, one other thing I should say about this is that if you look at this picture, you can see that it's actually quite difficult to know, or not to know, but it's difficult to calculate the stability of structures just because the geometry of how things change when you change the angle of a structure is difficult. So in this class, just so you know the level of expectation, I'm not asking you, I will not ask you to tell me, given a geometry floating there, whether it's going to be stable when I tilt it. But I do expect you to recognize, if I were to give you, let's say, the picture on the left here and the picture on the right, and I would expect you to be able to sort of identify the center of buoyancy, identify the center of gravity, and figure out whether it's a stable structure given these two pictures. I think that is sufficient in this case to be able to calculate whether, given two pictures, something is stable. I think you should be able to do that, but like if I only gave you the picture on the left, I would say that it's actually a little bit difficult to figure out whether it's going to be stable ahead of time. So I don't expect you to do that sort of calculation.